Students, this is the second part, video number second part of the video. Okay, so work done in stretching the liquid surface, the second part of the video. Okay, of surface tension. See, in the first part, and this is the second part, work done in stretching the liquid surface, liquid energy of a surface energy of a liquid. See, if you take a rectangular block, rectangular frame, and it you dipped into a soap solution, so it cover a soap solution like this. Okay, and there is a another rod type structure, suppose AB, and this is a PQRS, it's a frame. Now what happened, if you give a force like this in this way, F, then it always try to contract as small as area possible. And you know, students, the force of surface tension always acts in which direction? This direction, no doubt, because it always try to contract the area. Okay, or it always try to cover the smallest area. So suppose if you stressed by the applied force like this, the delta x is the delta x. Okay, so you know the formula of work done, W is equal to force into delta x, am I right? So giving a force F, you just displace the AB by the amount delta x, and the surface tension comes into play, and it always doing some work against your force, and it always try to contract as small as area possible. So if you stretched it, then the surface energy will work or work done occur, F dot dx. Now students, you tell me what is called surface tension. T is equal to force by length. Okay, force by length, say with me, surface tension equal to force by length, surface tension equal to force by length. Now see here, the length in two sides, both side, two sides, so you can multiply it by 2, so F by 12. So now force is equal to surface tension into 12, am I right? Say with me, F equal to surface tension into 12, surface tension into 12, force equal to surface tension into 12. Now put the value, F equal to surface tension into 12 into delta x. Now you tell me, why 12? Because there is a 2 surface area, because there is a 2 surface area, so surface tension into 12 into delta x. Now length into delta x, this is the length and this is the delta x, this is the length, this is the delta, that is breadth, length into breadth, length into breadth, length into breadth means the change of area, because delta x. So you can write surface tension into change of area. See students, this is the change of area, I think all of you agree with it. This is the change of area, this is called delta, this is the change of area, this is called delta. So surface tension into delta A is called surface energy. Okay, this is called the surface energy. So from this way you can finding the work done or the surface energy. Next question, you just pause the video and write it down in your copy. Okay, and prepare surface tension. Okay, next, what you read? Capillarity. So students, what is called capillarity? What is called capillary tube? It's a hair thin, very thin, hair thin like structured tube. And if you see this type of tube in your book, it made it very wide, but actually the tube is very narrow, like hair thin, like hair thin. So if you dip into the water, then what happened? The water rise up in this tube. Where you have seen this type of tube, you know, the roots, the root of the trees, the and the porous in your the sponge. Okay, or you always use towel to uh, wet your body while from bathing. Okay, so in the towel there is a fine spore, and from this it will absorb water. Okay, so these are called the capillary capillary tube. Now Ascent formula. Okay, see, the liquid, the water always rise up through this tube. Now see this diagram. Here if you draw the tension, okay, this is the tube and this is the water surface. Now this is the water surface. Now if you draw the tension T, okay, now you can see the water rise up due to this tension component. So this is theta. Okay, so water rise up in this way. See, water rise up in this way. So this is the water surface inside the tube. So if you draw the tangent, this is shows the tangent, and this is theta. So here is T cos theta and here is T sine of theta. Now you tell me, why water rise up through this tube? Because of T cos theta. And here is the length, means the free surface of the liquid, which is called 2 pi r. 2 pi r means the circumference of the circle, means it's the length. So force equal to surface tension into length means 2 pi r. Okay, now this force actually carrying the liquid column. I think you couldn't understand. See again, actually now I'm drawing. See, suppose this is a capillary tube and water rise up in this way. Now actually this tube carrying water column in that much, means that much liquid it carrying with the help of what? Surface tension. Understood? Due to surface tension actually carrying this type of that much of water. Now see, suppose if you draw the tangent, this is the surface of the liquid and this is the air. So this is the tangent. Now why water rising up? Because of this component, T cos theta component. Because of this T cos theta component. And this is theta, angle of contact, and here is the T sine theta. I think now you understood why water rise up. Because of T cos theta. And this is called the surface tension component, and into 2 pi r. 2 pi r means the circumference. So this is called the force. Force equal to surface tension into length. Length means here 2 pi r. Okay, 2 pi r. So now you can write force equal to 2 pi r into T cos theta, and that force responsible to carrying the liquid, which is we can write the volume into density. Here is the volume in the cylindrical volume, so you can write pi r square L, length. Okay, so here we can write h. H is the length of the liquid column, into density is rho, into 2 pi r into T cos theta. So pi r square h into rho equal to 2 pi r into T cos theta. Now see what your book says. Say this is this. You can ignore this calculation. Okay, you can write what I have written. T cos theta equal to pi r square rho into g. Okay, see. So 2 pi r T cos theta is equal to pi r square h, this is called volume, into density rho into g, m into g, actually mg. Mg means this is mass and this is gravity. So now pi cancel, r cancel, so h equal to 2t cos of theta by h rho g. Where is r? R, oh sorry, R rho g, R rho g, R rho g. So this is the calculation. So surface tension T equal to 2T cos theta, 2T cos theta by R rho g. H equal to 2T cos theta by R rho g. Okay, this is the height actually occupied by the. So in the next class, students, then you read some practical example of the capillarity. Okay, so students, in the next class, so in the next live class, I will discuss about the surface tension. Okay, I will discuss about the surface tension. Okay, so till then you just read from the book, and in the live Zoom classes I will discuss you about the surface tension thoroughly, then you can understand. This is actually तुम लोगों को बूस्ट अप करने के लिए है। जो होमवर्क क्या होगा, तुम इस वीक में सरफेस टेंशन पूरा कवर कर लोगी और बुक से पढ़ लोगी, ये सब पढ़ लोगी। ओके, टिल देन गुड बाय। सो नेक्स्ट क्लास फ्राइडे आई विल डिस्कस यू अबाउट द सरफेस टेंशन। ओके, चलो।